Hey everybody, I just wanted to take a minute to talk about the Fury 325 cracked support and give you a little background information on roller coasters in general. So, every amusement park ride at every park in the United States goes through a daily inspection. And when it comes to roller coasters, especially wooden roller coasters, the maintenance staff will walk the track. Because if you've ever noticed when you're riding a wooden roller coaster, there's catwalks on each side of the track system. So they will go through and they inspect the stack. And the stack is the layer of boards that make the road track surface. And while they're doing that, they look for loose bolts. They look for track rail that may be detaching from the surface. And they make repairs on the spot. And while they are up there, because they have the catwalk available, they can look at the immediate ledger and top of the bent for any structural issues. Because most structural issues will occur at the ledger, which is the piece that goes this way, and then the track sits on top on each side. Steel roller coasters, on the other hand, do not have catwalks past the lift. And then they don't usually appear again until the mid-course brake run and the final brake run. So it's not as if you can walk the entire track and look for issues and defects. However, steel is a much more rigid construction material than wood. So an inspection for track elements and supports would normally occur in the off season. And in that case, what they would do is they would get a construction lift. And that lift would then raise the inspector up, and they will inspect where the track connects to another piece of track, where it bolts to the support. And where the support bolts to the footer in the ground. This particular support is like this. Okay, and right here where my middle finger is wiggling, that's called the throat. And there's a throat weld there. And if you look at the support in the videos, the throat weld is not completely visible because the track moves at a 90-degree banking around that support. So it hides part of the throat weld. And there's blind spots in everything. Blind spots when you build cars, blind spots when you build roller coasters, blind spots when you build a house. They're just things that you cannot always see. Now, the crack, as we've seen in the video, definitely expanded significantly. But if it started in the throat weld, which is where it looks to have started, it might have been a minor defect in the weld itself that was not noticeable at first. And then as time went on, it began to expand. Now, there are reports on social media that somebody was at the park a week earlier and they have a picture of the crack in a much smaller nature, but yet they said nothing to the park. Which kind of irks me, because if they noticed it, why didn't they run to the park and give them a call and say, hey. I worked in an amusement park years ago, and I worked on both a steel roller coaster and a wooden roller coaster. And if we had a problem with the steel roller coaster, normally it would stop either on the brake run, the final brake run, because we didn't have a mid-course, because it was a smaller coaster, or it would stop on the lift. And the lift would allow us to walk up the stairs, aka the catwalk, where we could go and talk to the guests that were in the stopped vehicle and let them know that either we were going to have to get them out of the ride, or we were going to need a few minutes and then we'll restart the ride. Now, in this case, steel coasters have different mechanisms. You'll see sensors or little cameras throughout sections of the ride that pick up on certain things. And some of those are the position of the lap bars. Are they locked? If one lap bar that may have allowed the train to be dispatched, say, becomes loose as it's moving towards the lift, there is another safety mechanism in the track, in the design, that will count the lap bar positions. And if one lap bar is out of a position that the computer was programmed to recognize, it will stop the lift, meaning it will not allow the coaster to proceed. In this case, this occurred on a support column in a very high stress area. So based on the design of the ride and the numbers it puts out, it is anticipated that in that curve, Fury 325 is moving at a pace of 70 to 80 miles an hour. And that is a lot of speed at that angle of the track, because it is banked at 90 degrees or slightly over 90 degrees. And the outward forces, due to the speed, because you got to figure when you're entering, you're going to be pushing outwards as you're entering, and then it's going to be pulling inwards as it's exiting. It may have been an under-engineered design in that the forces anticipated in the design process using computer-aided drawing, or CAD, may not have anticipated the full amount of the force over a long period of time. And that's something that may not have come up during test runs when the ride was, finally constructed and they begin testing before they open it to the public. All of the data could show that, okay, it's hitting these forces at this speed with X amount of weight in the train, because they'll use what they call water-filled dummies to simulate humans. And then they take that data, and it's determined based on the data and X amount of test runs, which is known as a validation cycle, for them to determine whether the ride is safe or not. And B&M, Bollinger and Mallard, is the name of the company that designed and built this ride. They have a damn near flawless track record on safety. And their roller coasters actually changed the industry immensely. Because before, the steel manufacturers prior to B&M, their rides were very rough. Because they didn't use computer-aided design to design their rides. And if you look at a B&M roller coasters, they're very smooth. So now, those worrying about the supports. If you notice, before the crack support, there's a support on before that support and after that support. Now, those supports, coupled with the design, the box design of the track, will then take up the stresses of the support that has been compromised. But it is not meant to be a long-term solution. So, those that are saying that the ride could have ran as is, no. That not would have happened, because over time, while those other two supports are helping absorb the stress of the compromised support, they too will now be put under more stress than they were originally designed for. So this is not something as simple as letting it run as is or re-welding the support. This will require an extensive process. So per the laws of amusement ride certification, now I live in Pennsylvania, it's a little different, but the concept is the same. Any ride with a structural failure will require what's called red tagging, which means the ride is no longer authorized to be open to the public. It will then undergo a thorough investigation. B&M, the designer, has already been to Carowinds looked at what has occurred, and are formulating a corrective action. So now that they see what happened to the support while it's still in place, the ride will be disassembled in that section, and that support will then be taken, analyzed, and it'll determine what the exact failure was. The throat weld is definitely where it started, but was the grade of steel used not up to B&M specification, because they did have it fabricated at a plant in America? Or is it a design issue in that there's just too much force at that point of the ride to use a support of that nature, and then they would need to redesign the support? Or could it be that the turn is just too tight in general, which is going to exert way too many forces, and then they would need to reprofile it, which means they would take apart the roller coaster before it enters that curve till the point it exits that curve. And then they would have to pour new footers, cement footers in the ground, fabricate new track and supports, which they're going to have to do anyways, because you're not going to want to reuse the first support, the support that broke, or the support that's after that support, because they've already been put to more stress than they needed to be. So those three will be replaced right off the bat. If they need to fabricate brand new pieces because they have to reprofile the layout, that's going to take time. And then, because of the type of failure this ride will require a thorough support and track structural inspection, which means they will need to get construction lifts and cranes, and an individual will have to look at every single weld, every single connecting plate, every single column that is bolted to another column. And they will have to also have metal fatigue analysis to determine if there are any other areas of concern on the ride. This is not something that's going to be done in a week. This is not something that's going to be done in 2 weeks. It's going to take a significant amount of time. Just like the structural failure on El Toro at Six Flags Great Adventure. They had to shut the ride down for the remainder of the season, and they had to rebuild a significant portion of the structure in that one area. And then they also ended up retracking the ride to make it smoother. But El Toro was shut down until June of this year, and it closed in the summer of last year, 2022. Do not expect Fury 325 to open before the Halloween festival. It would be the earliest. But based on previous incidences, even with wooden roller coasters, mostly because that's where that has occurred due to forces, the rides usually stay shut that season, and they will reopen the next year, because not only with the investigation and then possible reprofiling, refabricating, and reinstallation of the compromised area, it's going to have to undergo extensive testing, and then the ride has to be re-cleared by the state board that certifies amusement rides. And because this is a structural failure, the board doesn't just sign off willy-nilly. They'll ask for X amount of cycles. So that means they will have to run every single train that that roller coaster is equipped with X amount of water dummy body weights. So they'll start with a full train of body weights, might be a half train, might be a quarter train, broken down into percentages, spread out to show that the train can complete this course safely and effectively. And then they will also put monitor sensors in that area of the coaster. Even if it's reprofiled and it takes the forces away, they will still have to monitor the stresses in that area for a long period of time. They will then have to compile all that data and put it into a report. And then the state will come out and visually watch X number of cycles. Could be 10 cycles, could be 500 cycles. It depends on what their level of concern is, because you're not talking about a 100-foot high roller coaster. You're talking about a 300+ foot high roller coaster that hits speeds in excess of 90 miles an hour and pushes close to 5 Gs. That's 5 times your body weight. Okay, so that is a huge concern. But make no mistake, anybody who says they could just get up there with a welder and fix it, no. That support is so structurally compromised at this point, it's basically scrap metal. That's all it is. So the park is going to have to work with B&M. B&M is going to have to order a new support be fabricated if they decide that the support as designed is suffice. But I'm suspecting, due to the banking and the amount of forces and the speed in that turn, you're going to see that ride be reprofiled. Many roller coasters get reprofiled for many different reasons. Some are reprofiled because when they were designed, they were way too intense. A perfect example of this, and wooden coasters get reprofiled quite a bit. Because you got to remember, they're built by hand. Everything is cut by hand. The wood's cut by hand, all of it. Where steel's fabricated, so it can get down to very, very tight tolerances. But the last steel roller coaster, while it didn't have a structural failure, it was reprofiled, was Intimidator 305 at King's Dominion, which is also owned by Cedar Fair, who owns Carowinds. Intimidator 305, coming off the drop, the turnaround to get to the first airtime hill was too tight, and it was causing people to black out, or have gray outs as they call them. So they reprofiled it by widening the actual turnaround enough that it took the G-forces down. Now, there wasn't a structural failure, but there was a health safety issue. And King's Dominion and Intamin, the designer of that ride, worked together to eliminate that problem. And the ride's still pretty good from what I understand. I haven't rode Intimidator 305 since the reprofiling, but as I understand it, it's still a great ride. Some other rides that you may or may not be familiar with that have been reprofiled. And reprofiled is just changing the track, angle of ascent, descent. Not Son of Beast. Cedar Point's Mean Streak, before it was converted to Steel Vengeance. That ride was reprofiled on the second drop, about 2 or 3 years into its life. Another wooden roller coaster that was reprofiled was Hercules at Dorney Park and Wild Water Kingdom, which is also a Cedar Fair park. And they no longer have that ride because it just, after 14 years of operations, it was just way too rough. You could constantly rebuild the turnaround down by the pond, and it just was not smoothing out in any way, shape, or form. And because they decided to put trim brakes at the top of the drop to slow the ride down a bit, it would cause the ride to valley, and which means that it couldn't make it back up onto the top portion of the ride in order to complete the course, and it would stall out. So they ended up reprofiling that section of track by lowering everything by 20 feet. And that was enough to get it to make it through the rest of the course, barely. Other rides get reprofiled due to stress forces. Knoebels has a roller coaster called Twister. And as you enter what they call the Helix or the Rose Bowl, the track didn't have a significant amount of banking when it was built. So the train, as it would traverse through that area, would put a lot of high stress on the track and the supports. Excuse me. A couple years into its operation, they ended up, because every year they would have to rebuild that section of track. And there's roller coasters, especially wooden, that have to have sections completely redone every single year. But that particular one had to be completely rebuilt every single year. Sometimes throughout the year it would need new top layer track or a couple layers in the stack. So they opted to reprofile it. Now, it's still, the Rose Bowl is still the same, but instead of it going in more flat, it goes in more banked. So it takes the stress off of the supports, because when it was flat, the ride's pushing outward. But now that it's banked more, it's evenly distributing the forces. It doesn't change the ride that much. The only thing is it takes a little more of that out of control feel away from it, which I thought was a great element as somebody who's rode or ridden, or whatever word you want to use, Twister a lot, especially the first year it opened. But that's what happens when you're dealing with a roller coaster. Again, it's not going to be safe to run it as is. You can't just simply weld it together. As far as, are they inspected? Every roller coaster is inspected every single morning. Steel coasters are run more cycles than a wooden coaster. But the areas that do have catwalks, maintenance will go up and inspect the brakes, the track. They will make sure that the sensors are working and triggering as they're supposed to be, because everything is run by a PLC system, or short-term computer, or Pro Logic controller. And they will walk the brake run and inspect all the brakes on the brake run. They will inspect the trim brakes, if there are any trim brakes in the ride that allow the ride to slow it down a bit if it's moving too fast. They will inspect the lift, the chain. They will inspect the entire train. That includes the dogs, the chain dogs, which is what hooks into the chain to bring it up. And then they'll check the anti-rollbacks, which is the thing that makes that click, 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 click noise. Because if any of one of those are not up to standard, they could cause the roller coaster to roll backwards. If something happened to the chain, if the chain broke, the anti-rollbacks stop it from rolling back. But if one of the dog catches, that's what they're referred to, breaks, then the roller coaster could slide backwards. However, there's redundancies in that every section of the train can have a dog catch. Or they might only have one every other row. So that's a 7-row train. So they might have one at row 1, row 3, row 5, row 7, or they could have one on every single row. So if one breaks, the other ones are there and it'll still hold it. If the chain catch breaks, the anti-rollback kicks in. If all the anti-rollbacks broke, but the chain is still intact and the train is still attached to it, the chain would secure the train on the lift. Now, if the train did roll back, if you notice, before any lift on a steel coaster, you usually see a brake run, a short brake run. It's enough to catch the train coming down, to slow it enough, or to stop it completely so that it doesn't reverse itself back into the station and possibly bang into another train. So all of these coasters have this. And then in the off season, again, they'll get a construction lift or a basket on a crane to inspect the portions of track they cannot walk. And that includes everywhere where you see the spine connecting to another spine. That's every single bolt. Where the track meets the support attachment, that'll be inspected. And they will actually go through and retorque all of the connectors. So if there's bolts on the track or the puller, they will test the torque, and if it's not up to the manufacturer specification, they will retorque it. If they notice that the connecting bolts are degrading in any way, they will then pull them out and put new ones in. And that occurs quite frequently, especially in areas of the country where the weather changes severely from season to season. Road wheels, everything. You know, the wheels have a urethane cover on the part that rides on the top of the track and also on the sides. Those get replaced as they wear out. The brake fins that are part of the caliper braking system, or the magnets, depending on what type of braking system ride is equipped with, as they begin to wear, they will replace those. There is an entire, what they call an owner's manual, more or less. It's like your car book that tells you the recommended maintenance at what intervals and what you should exactly look for. But every single morning, the coupling of the train, how each car connects to the next car, the wheels, the suspension, the steering assemblies, the lap bars, the seats themselves, the seat belts. Every element of that train is inspected, as well as every mechanism, including the lift motor, the lift, the chain, every sensor, the brakes, the brake run, etc. Those go through that every single morning, and then in the off season, they will then do a thorough inspection of the supports. And there's chances are that this crack hadn't developed during that inspection, or it was developed and it wasn't visible during the inspection. It doesn't take much. Once something starts, it's only a matter of time before it expands. Now, is it to say that they couldn't have noticed it? I mean, I don't know about anybody else, but when I worked at the park, even walking to the ride that morning, whichever one I was on, the steel coaster or the wooden coaster, I was always looking for something, you know, because I didn't go through the exit ramp. I would walk through the entrance, which actually took you through the substructure of the ride. And I was curious. I'd look at everything. I'd look at the chain. I'd look at the track coming out of the tunnel for that ride. And, you know, is everything there? And then when you get up to the control panel, you have to start everything up. And wooden coasters are very old in that it was actually a multi-speed transmission that got the lift up to full speed. You would have to get that going, and then you have to send each train on a test run, empty, before you can let one passenger in. So if I was the first one on the platform, I would be the one to make sure all the lap bars were checked. I'd send the train out empty, get the next train ready, send that one out empty. When it's time to do the circuit, if they come back and there's no issues, go down to the brake run part of the track, reach over and slide the gate open to open the ride for the day. And then wait for the other employees to show up, because you can't run a roller coaster with passengers by yourself, but to do the pre-inspection, it's fine. But that's what every amusement park requires of their staff. Steel coaster was the same way. Come up, I would look around the supports, you know, see anything was out of whack, check the hydraulic lines if I can see them visibly, see if anything was leaking. And if there was, I would call maintenance and say, hey, meet me at such and such ride. There's a hydraulic line leaking on the brake run for, you know, the loop coaster, or, you know, the skid brakes on the wooden coaster. One of the skid plates is coming up. And they would come over and they would fix it, and then they would re-inspect that area, retest the ride, and if it can be reopened, it gets reopened. If it doesn't, it stays closed until they get it fixed. But that's what happens every single morning. At night, when you close the ride, if you're running two trains, you may not be able to park both in the station. You might have to park one on the lift, and you park one on the brake run. Steel coasters, they're always parked in the station or the transfer track. And in the morning, maintenance will come in, and then they will go to the PLC system and trigger it to have faults. Or they will set the lap bar sensor just enough to where the pedal counter or the lap bar counter will notice that it's out of whack, and it stops the ride on the lift. So trust me, inspections are thorough. At least at the park I worked at, they were. And I'm sure Cedar Fair, which has been in the business for a long time, It has a lot riding on their reputation. It has the same thing. However, again, because it's steel and you can't walk the whole track every day like you can a wooden coaster, there are going to be limitations. And some of those inspections will occur in the off season. And this past year was the first time the 325 ran all year. So it ran through the winter months, and it ran through the spring, summer, fall. It ran all the time. So, and Carowinds was only open on the weekends after Labor Day until Memorial Day this year. So during the week, they would have to do those inspections. And remember, you have less daylight in the winter months. So as they're doing the inspections, what could normally be done in a week or two with the ride constantly being closed now has to take place because the ride's supposed to open that weekend, or at least they hope to open it that weekend. So they'll inspect so much, move to the next part, inspect so much, etc., etc. So these are some of the things that you should keep in mind when you're thinking about roller coasters. And if you really want to watch a great series on roller coasters or the operation of roller coasters, general knowledge, look up El Toro Ryan, and he has a video series called Problematic Roller Coasters, and he goes over why those coasters had problems, what was done to remedy those problems, or possibly why those coasters are no longer with us. The guy is amazing, and he has extensive knowledge about El Toro at Six Flags Great Adventure because he used to work there, and he worked on El Toro. And he has a video about the structural failure on El Toro that happened last year. And I think it'll give you a general idea of why structural failures are very concerning. Excuse me. And it'll help you understand more about what happened to Fury 325. Thanks, guys. Have a good one, and I hope this information helped.